Hello everybody, today we are back here at a new lesson on a new example regarding nodal analysis. As we have seen last week, we have a circuit and we've got some currents entering that node, we've got currents leaving that node, and we learned that the sum of currents entering and leaving that node is going to be equal to 0. So the total sum of currents entering and leaving that node is equal to 0. We've got no losses in there. It's a lossless question. So, to find Ix, which is what is needed here in this question, we're going to have to find an equation for Ix. Looking at Ix, let's call this node as node 1, let's call this as node 2. And for Ix, it's going to be the voltage difference between node 1 and node 2, taking into regard the direction going from 1 to 2, so 1 minus V2, all over the resistor of which the Ix is passing through, which is 10 ohms. So this is the equation to find Ix, and for that purpose we need to find V1 and V2. So we're going to have two different equations regarding two different unknowns, which are V1 and V2. Once we find the values of them, we can directly replace them back in this formula to get the value of Ix. So this is what we're going to be doing throughout this question. Moving on to this smaller drawing of that equation, of that circuit, we have called this voltage here as V1, this voltage here as V2. We're going to go through V1's node first to find the answer for V1, V2 equation. And we're going to find another equation regarding V1 and V2 in V2 node. Using that, we're going to find our solutions for V1 and V2. So for V1, we're going to look at this node. We have this current entering the node. We're going to consider this I1 current leaving that node along with Ix. So we've got two currents leaving the node, and one current is entering that node. So currents entering the node, which is 9, is equal to the current leaving that node, which is I1 plus Ix. The value for I1 is going to be V1 over 20. 20 is this value of resistor that the I1 is passing through. So V1 over 20 plus for Ix equals to 9. Taking 9 to the other side, we've got minus 9 plus V1 over 20 plus V1 minus V2 over 10 equals 0. Multiplying the whole equation by 20 to cancel these denominators. We're going to get 180 equal to, we're going to get V1 plus 2V1 minus 2V2. Therefore, we've got 3V1 minus 2V2 equals 180. We're going to have a KCL V2 minus V1 over 10 is current running through this direction. We are assuming V2 minus V1 over 10, as this is leaving, is going to be positive. Entering the node is going to be negative. We've got minus 5Ix. Entering that node, again this is also leaving, so it's going to be positive. V2 minus 45 over 10. Replace this equation right here. Equals to 0. So this is what we have reached to, and we're gonna have to replace Ix by, as we know, Ix was V1 minus V2 over 10, as we had first mentioned. We're going to replace this into Ix down here. So we have V2 minus V1 over 10 minus 5V1 minus 5V2 all over 10 plus v2 minus 45 over 10 equals to 0. We're going to multiply the whole equation by 10. So we've got v2 minus v1 minus 5v1 minus 5v2 plus v2 minus 45 equals to 0. Minus 45 goes to the other side. We've got minus 45. We've got all the v1s and v2s in one area. So we've got minus 6v1 plus 7v2 equals to 45. Keep in mind when we expand minus 5ix, it's going to be minus 5v1 minus v2 over 10. And then we take this minus 5 inside, it's going to be minus 5v1 minus 5 minus v2 is going to be plus 5v2 all over 10. So we multiply by 10, we've got a minus 5 coming out from this equation and a plus 5v2. This is why we've got v2 as a positive value and then negative value for v1, negative 6. This is the second equation. As you can see, we have reached to this, included this equation. We've got two equations in terms of v1 and v2. 3v1 minus 2v2 equals to 180. We've got another equation that says minus 6v1 plus 7v2 equals to 45. We need to eliminate one of the two variables. Now that we see v1 can be eliminated by multiplying the first equation by 2. Then we're going to get 6v1 minus 4v2 equals to 360. Once we get that equation, we're going to focus on these two equations, add them up. These get cancelled. Minus 4v2 plus 7v2 is going to be 3v2, and adding 360 plus 45 is going to be 405. So dividing both sides by 3, we are going to divide 405 divided by 3 is going to be 135, which is equal to V2. So V2 equals to 135 volts. Once we get this answer, we're going to replace it in V1 value. And to replace it in V1's value equation, we can choose replacing this V2 value in V1's equation of 1 or 2. So I will choose 1. So 3V1 is going to be equal to 180 plus 2V2. I took this to the other side. Therefore, 3V1 equals to 180 plus 2 times V2, which is 2 times 135, which is 270. 270 plus 180 is going to be equal to 450. 3V1 divided 3 both sides. V1 is going to be equal to 150 volts. Once we've got the value for V1 and V2, which is 150 and 135, we can go to the original equation we have formed, which is Ix equals to V1 minus V2 all over 10. We replace the values, which is 150 minus 135 gives us 15 divided by 10 equals to Ix. That gives me 15 over 10. So the value for Ix is going to be equal to 1.5 amperes. Hope you guys enjoyed this question and understood everything in this question. And if you need anything or any question, just get back to me. I will be more than happy to help. Thank you everyone for listening to me, and hope you